Hello everyone, I am Dr. Krishna Sarker, Department of Electrical Engineering. Here in this session, I will be going to discuss about Laplace transform. Formula of Laplace transform, inverse Laplace transform, differentiation theorem and properties of Laplace transform. This is lecture series on control systems, mathematics and network theory and lecture number 5. So our new topics: formula of Laplace transform, inverse Laplace transform, differentiation theorem and properties of Laplace transform. Then overview. What is overview? What is Laplace transform? First point, what is Laplace transform? And what is inverse Laplace transform? Region of convergence. Derivation of Laplace transform of simple function like unit step function or ut equals to 1, ramp function rt equals to t, parabolic function et equals to t square, exponential function e to the power at or e to the power minus at, and cosine wave function. This is cos omega t. Another overview, sine wave function like sine omega t, hyperbolic sine wave function, sine hyperbolic omega t, hyperbolic cosine wave function, cosine h omega t, and Laplace transform of an integral t to the power n. Laplace transform of e to the power minus alpha t sine omega t. Laplace transform of e to the power minus alpha t sine h omega t, or hyperbolic h is hyperbolic omega t. Another overview, Laplace transform of e to the power minus alpha t cos omega t, and Laplace transform of e to the power minus alpha t cos h omega t. Laplace transform of impulse function delta t. Importance properties of Laplace transform. Importance properties of Laplace transform. What is the importance properties? Theorem 1, linearity property. Theorem 2, superposition properties. And Theorem 3, real differentiation. And Theorem 4, translation in time. Theorem 5, translation in time domain. Theorem 6, complex differentiation. Theorem 7, real integration. Theorem 8, initial value theorem. Theorem 9, final value theorem. And Theorem 10, complex integration. Another part, engineering application of Laplace transform or real life application of Laplace transform. Then what is Laplace transform? The basic definition or formal definition of Laplace transform. The Laplace transform of a time domain function f of t, which is defined for all real number t greater than equals to 0. It is assumed that the value of the function is 0 for t less than 0, and also which is represented by f of s. It is an unilateral transform, and the Laplace transform of the time domain function f of t is given by Laplace transform of f of t equals to f of s equals to 0 to infinity f of t e to the power minus st dt. So in this case, f of t, our main function, this is our main function, and after Laplace transform of f of t or function equals to f of s, that means time domain to frequency domain, and which is defined as all real number t greater than equals to 0. Suppose this is the axis, this point t equals to 0, and this is satisfied t equals to 0 to t greater than 0, that means this direction, but t less than 0, this side. Assume that the value of the function is 0 for t less than 0, and integration, this is unilateral because only this portion 0 to infinity, this portion 0 to infinity, function of f of t to the power minus st and into dt. This is the Laplace transform formula. The symbol L stands for Laplace transform of. That means Laplace transform of function of t or Laplace transform of f of t. Then where f of t is a function in time domain and fs is a function in complex frequency, and it is given as s is equal to sigma plus j omega. This is the very important part, sigma plus j omega, where sigma is the real part of s and omega is the imaginary part of s. So sigma is real part and the unit of sigma is nepar and unit of omega is rad per second, where s is the intermediate or transformed variable and it is a part of the exponential function. It is a part of the exponential function. So s is the part of the s is the part of exponential function. This is actually our main point in this. Yes. Then it is obvious that Laplace transform changes a function in time domain into a function of frequency domain. This is the time domain function and this is the frequency domain function. So changes time domain to frequency domain for Laplace transform. And when inverse Laplace transform, frequency domain to again time domain. So next case, what is inverse Laplace transform? So inverse Laplace transform, just as fs is the Laplace transform of f of t. F of t is the inverse Laplace transform of f of s. Inverse Laplace transform permits to go back from s domain to t domain. That means again f of s to f of t. This is the inverse Laplace transform and this is the formula. The inverse Laplace of f of s equals to f of t and this is equivalent to 1 by 2 pi j minus j2 plus j f of s e to the power st ds. Another formula, inverse Laplace of f of s equals to f of t equals to 1 by 2 pi j sigma minus j omega to sigma plus j omega. Sigma plus j omega. This is the inverse Laplace transform formula. Then bilateral Laplace transform. The bilateral Laplace transform f of s is defined as follows. F of s equals to Laplace transform of f of t minus infinity to plus infinity f of t e to the power minus st dt. In this case, range minus infinity to plus infinity. That's why this type of Laplace transform is called bilateral. This is 0 and this is the minus infinity. This is the plus infinity. For bilateral Laplace transform, this is the minus infinity to plus infinity range. Then region of convergence. If f of t is a locally integrable function, then the Laplace transform fs or f of t converges provided that the limit r tends to infinity 0 to r f of t e to the power minus st dt. This is the formula for region of convergence. Limit r tends to infinity, that means 0 to infinity f of t e to the power minus st dt, where s is equal to sigma plus j omega, and which is exist. And the Laplace transform converges absolutely if the integral minus infinity to plus infinity mod of f of t e to the power minus st d of t exists as a proper integral. The region of convergence or ROC for all is with real s greater than real s of 0 or initial value. So this is our region of convergence formula and properties, boundary conditions. So Laplace transform table. This is the formula. Formula of Laplace transform and inverse Laplace transform. What is the formula? This is the first formula. Laplace transform of 1, this is the unit step function, equals to Laplace transform of u of t equals to 1 by s. This is the Laplace transform formula. And inverse Laplace formula, inverse Laplace of 1 by s equals to 1. Laplace transform of t, Laplace transform of t means ramp function. This is the ramp function. This is the ramp function. And this Laplace transform of ramp function equivalent to 1 by factorial 1 by s square, and inverse Laplace of factorial 1 by s square equals to again t, and Laplace transform of t square, this is parabolic function, equals to factorial 2 by s cube, and inverse Laplace of 2 by s cube, factorial 2 by s cube equals to t square, and Laplace transform of t to the power n equals to factorial n by s to the power n plus 1. Similarly, inverse Laplace of factorial n by s to the power n plus 1 equals to t to the power n. So these are all Laplace transform formula. And another formulas, e to the power at, Laplace transform of e to the power at equals to 1 by s minus a. Similarly, inverse Laplace of 1 by s minus a equals to e to the power at. Laplace transform of e to the power minus at equals to 1 by s plus a. Similarly, inverse Laplace of 1 by s plus a equals to e to the power minus at. Laplace transform of sine omega t equals to omega by s square plus omega square. Inverse Laplace of omega by s square plus omega square equals to sine omega t. And Laplace transform of cos omega t equals to s by s square plus omega square. Laplace transform of s, inverse Laplace of s by s square plus omega square equals to again cos omega t. Another formulas, Laplace transform of e to the power minus alpha t sine omega t. This is a very important formula, omega by s plus alpha whole square plus omega square. And inverse Laplace of this function, that means omega by s plus alpha whole square plus omega square equals to e to the power minus alpha t sine omega t. And for cosinusoidal function, Laplace transform of e to the power minus alpha t cos of omega t equals to s plus alpha divided by s plus alpha whole square plus omega square. And Laplace transform of s plus inverse Laplace of s plus alpha divided by s plus alpha whole square plus omega square equals to e to the power minus alpha t cos of omega t. So formula of Laplace transform and inverse Laplace transform, another formula, sine hyperbolic omega t, that means Laplace transform of sine h omega t equals to omega by s square plus omega square. Inverse Laplace of omega by s square plus omega square equals to sine h omega t. This is frequency domain to time domain conversation. And Laplace transform of cos h omega t equals to s by s square plus omega square. Similarly, inverse Laplace transform of this part, s by s omega, this is the s. This is the s by s square plus omega square equals to cos h omega t, cos h omega t. Then Laplace transform of delta t equals to 1. This is the impulse formula. Laplace transform of impulse function equals to always 1. And the formula, another formulas, Laplace transform of e to the power minus alpha t cos h omega t equals to s plus alpha divided by s plus alpha whole square minus omega square. And inverse Laplace of this function equals to inverse Laplace of s plus alpha divided by s plus alpha whole square minus omega square equals to e to the power minus alpha t cos h omega t. And inverse Laplace transform of e to the power minus alpha t sin h omega t equals to h by alpha s plus alpha whole square minus omega square. Similarly, inverse Laplace of omega by s plus alpha whole square minus omega square equals to e to the power minus alpha t sin h omega t. So these are all formula or Laplace transform. And differentiation theorem in Laplace transform formula. What is the differentiation formula of Laplace transform? Let f of t be a function of t and let f of s be its Laplace transform. The Laplace transform of first order, second order, third order and higher order derivatives are. This is the first order differentiation formula. Laplace transform of first order systems equals to S of fs minus f of 0. Laplace transform of first order differentiation theorem. That is the f of t function. So df of t by dt is called the first order differential equation, and this first order differential equation Laplace transform is equals to S of fs minus f of 0. And second order system, for second order differentiation theorem for second order systems, L of d2ft by dt2 equals to s square fs minus s of f0 minus f dash 0. This is our second order differential equation formula. And for third order formula, differentiation theorem of third order differential equation, Laplace transform of d3y f of t by dt3, d3 f of t by dt3 equals to s cube fs minus s square f0 minus s f prime 0 minus f double dash 0. This is for third order system. For nth order system, Laplace transform of d to the power n f of t divided by d to the power n equals to s to the power n f of s minus s to the power n minus 1 f of 0 minus s to the power n minus 2 f prime 0 dot 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 s square f of n minus 3 triple dot 0 s of minus s f of f to the power n minus 2 double dot 0 minus f to the power n minus 1 dot 0. This is the nth order differential equation. Laplace transform of e to the power at. This is the example of Laplace transform or proof of e to the power at. Exponential function. Actually, this is exponential function. Laplace transform of e to the power at or f of t equals to e to the power at. So, what is the solution of e to the power at? The Laplace transform of the function e to the power at or f of t equals to e to the power at is represented by f of s. And it is given by, what is the formula? Formula f of s equals to Laplace transform of f of t equals to Laplace transform function e to the power at equals to 0 to infinity f of t to the power minus st dt. This is the formula, this section actually formula part. And then put f of t, equals to e to the power at. This is our main target. F of t function equals to e to the power at, and what is the Laplace transform formula? Then e to the power at, e to the power minus st dt. Put f of t equals to e to the power at, or Laplace transform of e to the power at equals to 0 to infinity e to the power minus s common, s t common minus s minus a t into dt. And this is equivalent to, what is the integration for e to the power minus s minus a whole on t? E to the power minus s minus a whole into t divided by minus s minus a minus into s minus a. This is the formula for integration, e to the power minus s minus a. And this is equivalent to minus 1 by s minus a e to the power minus s minus a whole into t integration. Put upper limit and lower limit, we get e to the power minus infinity. This is the minus infinity value, and this is the lower range or lower value e to the power 0. So put the e to the power minus infinity equals to what? This is equivalent to 0, and this function equals to e to the power 0 equals to minus 1. So ultimate our e to the power Laplace transform of e to the power at equals to 1 by s minus a. This is the formula for exponential function. E to the power at equals to 1 by s minus a. And Laplace transform of e to the power at equals to 1 by s minus a. This is the formula for e to the power at. As the inverse Laplace transform is denoted by the letter L inverse, and therefore the inverse Laplace transform 1 by s minus a is e to the power at, and expressed as inverse Laplace transform of 1 by s minus a equals to e to the power at. This is the inverse Laplace transform formula, and this is the Laplace transform formula. Laplace transform of e to the power at equals to 1 by s minus a. examples of the Laplace transform and applications of the Laplace transform. The Laplace transform is used frequently in engineering and physics. Laplace transform is used to solve the differential equations. The Laplace transform is used extensively in mechanical engineering, electronic engineering, applied engineering, and electrical engineering systems. Engineering application of Laplace transform: control system and process control, power system, machine and power electronics, analysis of electrical circuit or electronic circuit, and analysis of mechanical circuit, system modeling, digital signal processing, nuclear physics, mathematics, etc. This is the engineering application of Laplace transform. So thank you.